Hey guys, today we'll be doing lead code number 205, isomorphic strings. It is an easy question on lead code. Now, before I get to anything, let's first analyze what the question itself says. So, put it very simply, when they say no two characters may map to the same character, so if we say p, if p is currently allocated the value t, as in p is equals to t, it cannot simultaneously hold another letter s. So let's say if we had p equals to t and then we wanted to assign p equals to s, that would immediately say return false. Okay, but a character may map to itself in the sense that p can be equals to p. That's completely fine. It's kind of like the same one in pay. It's kind of like if you had p something like this, and then you had pile over here and you had like pale over here. That's still completely fine. Okay, so it can map to itself, it can map to itself, it can map to itself. The only condition that it fails is when like it maps to two different things. Okay, now if you know anything about functions, I won't go into extreme in depth about all of functions over here, but if you know anything about functions, you may know about bijections. And in bijections, we call it one-to-one, right? So if we had a domain x and we had a domain y, every point in x must map to only one point in y, kind of like this, right? And it's the same thing. So if we had an arrow going like this, it would no longer be a bijection, right? So every unique value of x, unique value of y. That's what we call one-to-one. And it's the same thing over here. So let's consider an example actually. If we do paper, T-I-T-L-E, if you look at this, P is equals to T, A is equals to I, P is equals to T, a repeat of this, it is completely fine. It's still not mapping to another character. E to L, that's completely fine, and R to E, that's completely fine. Since we've passed those checks where you know the same character can be equals to two values, then we can say this is still true, right? Now let's consider F11 B23. This is the best example actually, because F to B, that's completely fine, but if you see 1 to 2 and then 1 to 3, we've tried to allocate 2 and 3 to just 1, right? And that's what causes it to fail. That's why it becomes false immediately. So the way to approach this question, right, since I've drawn out like this function, you know, like this function explanation x and y, why not consider two dictionaries to be the same exact way? So if we say we'll do s to t, then we'll do t to s. Okay, we consider two dictionaries. Okay, and our goal here is to make sure that these two values, right, these two values, whenever they occur and they're equals to each other, as in p to t, the next time we see p, it should be equal to t. If not, we will immediately return false. So now if we have s to t, t to s, I'll write down the code here and then I'll explain it a bit further. So for I in range s, we are told that s is equals to t, so you don't need to write any other checks over here. Range len s, so if we see that, okay, the one that we are on right now, so let's say we were at p number 2, if si was already in our s to t, but if the value that we're trying to assign to it right now, so you could think of this one, okay, So FBB 1 1 2 3, if we had 1, right, this condition would pass right now. So we've put currently our dictionary for S to T looks like this: F to B 1 to 2. Now we are on to the next iteration and we are about to add 1. 1 will pass this check. If SI and S to T, that will pass. And S to T, the value that we have stored right now over here, if that is not equals to the value that we are at right now, in the sense that right now Ti would be equal to 3, right? Because we are looping through it as in 0 1 2. I considers these values 0 1 2, and right now we are in iteration 2, so we consider 1, we consider 3 only, and we see that okay, the one we have stored right now is 2, but 2 is not equals to 3, right? So in this scenario we would return false. Then in another case, if we do the same exact thing but the other way around, so T2S now, and the value we had stored for T, if the one we are at right now is not equals to that, then we can return false. Otherwise, just add the characters as they are. There's nothing additional to do. All we care about is situations where it fails, okay? We don't care about, it being right. It will do it itself. And if none, and in the entire loop, if we never get a return false, then we will return true, because that means everything is unique. Now I'll do another test run. So like I said, foo F11 and B23 was pretty good. I think there might be another example. Let's see. I'll consider BADC and BABA. Okay, so I'll write it out over here. So S to T and T to S. Okay, let's see. Our S to T at first would say B to B. That's completely fine. T to S would also say B to B. Right? To make it more clear. A to A, A to A. Now we are at D. Okay, we'll go 0, 1, 2, 3. Now we're at D. Our first check would say, is D in S to T? It isn't, no worries. We will say this, no worries right now. Don't even bother with it right now. Just say D to B. Right now it would look like D to B, okay? But in the first check, when we do S to T, D won't be caught, because SI in S to T, D isn't in S to T, right? So that check will say true for now, okay? But over here when we go to T to S, we will see that we want to try to write B to D. And like I said, the same thing with 1 1. We've tried to write B again with a different value. Right? And it's not equal to the one that was stored. B and D are not equal. So we would hit false immediately. So the true was just tentative, right? Because it didn't meet at that time. But this is the usefulness of bisectivity. That's why you have like these two counters. They both will check each other simultaneously. And you can catch cases like these, right? Now C to A. You would do C to A. A would say true for now, because C to A would go in completely fine. There's no worries. And we've already written false, by the way. So this program would have ended, but I'm just showing C to A again because there is the same thing. If we did A to C over here, it would do the same exact thing. So it would catch it. And we would return false for a second time, even though we already returned false. But that's it. And this over here, the time complexity for this is O of n. We loop through the S and T just once. We did set up two dictionaries, so in the worst case this could be O of n, 2 times of O of n, that's really just O of n. And that's it for this question. There's nothing more. The other question, word pattern, yes, word pattern, number 290 has the same trick. So if you want to, well, write it out by yourself now, you can definitely attempt word pattern 290. It is also an easy question. But that's it for today.